Welcome to this video about a general advice about how to record 3D data for a photogrammetric process. And we want to take here an example first with a simple example. Here we have this building where we want to fly with a drone and capture it in a good way in a 3D model. And then we will take a look to a more complex part. So let's start first. We have, in this case here, a 35 millimeter focal length. If I change my, okay, let's quickly take a look. So that means here, this is at the moment my distance with a 35 millimeter, and I would see this content here. And if I change my focal length and I make this, in this case, a 50 millimeter focal length, then we can see, of course, then here a smaller portion of the building. And this has, of course, then also an impact how to fly in a different way. So depending on what you have to fly with a different distance to this object here to cover it. And on the other side, also the resolution that you want to reach means if this is not enough, this resolution here that you get from the building is not good enough, and you need to fly closer in this case here, then of course you can fly closer, and then when you fly closer, then you have a higher resolution, but you then see also only portions of the building, which is not wrong, but then of course you have to take this into account. So in my example here, I just start here having with one image here the full bandwidth of the building, which is not common. We will take a look later on this, but just to explain the basics. What you will do normally is you fly around your building, and I would recommend to take every 5 to 10 degrees an image. So if you take every 10 degrees, one circle with 360 degrees, it means you would take 36 images. So that means in our case here, I would fly around and then take here an image, I fly 5 degrees further, here an image, fly around, here an image, around, here an image, and so on. And so I go around the building and collect, in this case, with an equal angle difference, here my 36 or 72 images if I take every 5 degrees a photo. And then we have here on one flying height, in this flying height we have taken images, which means we can't cover everything. We can't see, for example, here on top of this window. We have not image content that can see here on top, because at this flying height we are below it, so just geometrically not possible. And on the same side, we also cannot see here the lower content here and cannot cover this part here. And therefore, what is very common, you fly in different height circles. It's like strips. So this is my first, or normally you start at the top or bottom, and then you fly and take, again, 36 or 72 images, but now this time with your camera on a different flying height. So that means if I grab my camera, I put it up, then I would take here these images and then take these ones. At the moment I have here a constraint, so let me here change this here. Let us take here the other camera and make this active. So let me again show it here. So that means if I take here at this height an image, then of course this image, when I fly now on the next strip here, it should have an overlap. So if I go with the camera down and then I take a second image here, then this image here should have an overlap with this image here. And normally also we want to have here 60% overlap. That means if you take this image, then I would also take here another strip or circle around, and then take these ones here, these ones here, these ones here. And then you have also in between these circles, you have enough overlap that you can then create or extract interest points for our process. Finally, also, it makes a lot of sense also to take some images from top, because when we have an object like here, the roof, some other parts that are on top, makes also sense. So taking the camera here and then moving it, in this case here, on top, up, and then in this case here, point it down. So in this case here, so downwards in this case here, and then of course normally east-west or something like that. So then of course taking also here images along the roof, and then when you turn with your drone, fly the opposite direction again. This is the Nadir case, where you fly again with 70% overlap in strip, and then also with 70% here between the strips. Yeah, so very clear. This is how we would then also add some additional images, and that ends up, so we would then have here our circles or flights, where in this case we have an equal distance to our object. So from this circle to this object, we always have the same distance, which means all our images have a similar scale, which is very important because we want to extract interest points. And when in the different images we have always a similar resolution of our objects, then it's much easier for the image matching algorithms to find them. Same would be also, of course, for the images on top. That means this distance that I have from the object to the circle would be also similar, like from this roof to the top. So probably at this distance would make sense, because this distance from here to the object is similar like the distance from the object to the circle. Yeah, so very similar from this distance. And then we can easily extract our point cloud and also create our 3D meshes from it, because they have here a good scalability. Also, the accuracy would be similar from all these images. So as I mentioned, the objects have a similar scale, so we can achieve a very constant equal resolution for our final product. I'm not sure if I mentioned it at the beginning, but again, why 5 or 10 degrees? Because if you have lesser than 5 degrees, if you find too many images, then you get very narrow angles, and this is not good for mathematical solutions. And if you take too large distances, then the objects, the geometry starts to exchange very drastically, and then sometimes it's difficult to find the same object in two images because they look all of a sudden totally different in geometry. Of course, occlusion can also be a problem then, so you cannot then find the same content, which is important for the image matching algorithms again. Let's finalize a couple of things. Also, do not change the focal length. Always, when you have 12 millimeter, 35 millimeter, or whatever your focal length is, your fixed focal length, stay with your fixed focal length. Some drones don't allow this, which is great. But if you have the zoomable, then please do not change it, because we need to do always a camera calibration. Any software needs to do that. And if you have a fixed focal length, then we can here solve this in a good way. And therefore, this is then giving you a much better result and also a quality and stability in your whole 3D modeling approach. A couple topics also necessary to talk is illumination. Especially for the 3D modeling, because we always have an object that is, in this case here, throwing shadows in different ways. So the best thing would be, of course, if you would have a cloudy day. In a cloudy day, then we would then have a more diffused light, and therefore this would then not cause shadows. We would then have equally texture on our different parts of our object. So it looks more homogeneous. It is also allowing for the image matching. It has lesser troubles. If you have a sunny day, then of course you have shadows that are caused. They can be caused by anything, by overlaying stuff. Also here, you see here, for example, of course I have here extreme part, but also our window border here is throwing a shadow down here, causing here to to cause here edges, and therefore this can also cause trouble. The further the sun is, in this case here, during the day moving, you see also that during a day, so if you fly for so if you fly here during the day, also, let's say the sun would move by 3 or 4 degrees, then of course also your shadow will move by 3 to 4 degrees. So this is then all causing then different troubles. So also then the illumination of the roof is stronger. If I increase the sun intensity, then this can then also cause then overexposure. So if I go on the other side, then you have also here very dark shadowed parts and very bright parts. And this is of course then also a more complex problem to be solved and causes also a lesser accurate solution. So therefore try to fly if possible on a cloudy day. Finally, also the drone itself. If you have an RTK drone, this is very helpful because then we have very good pre-positionings already from each exposure from the drone, and each drone also can then be similar like a control point, and therefore then help us for the camera calibration. If you don't have this, then of course you should then place control points that are visible from further away directions, which would be helpful. So again, let us perhaps here take a look here. So at the camera view, so if this is my camera looking here down, this is now of course easy, but let us again go back to the other camera. So, and when we take a look here, then we can see now here that we don't see here in front of the ground on the higher strips. So therefore, it can help to have on the facades also some targets. Some people are putting them here, typically here, some signalized control points. Or if you put it on the ground, then try not to put them too close at the edge, but give it a little bit distance, about 4 to 5 meters. So there is a larger advantage to get them correctly extracted. This helps them to find them here and to measure them. Okay, so this was the simple part. And now, of course, what if the object is more complex? So instead of this simple squared building, what if we have a building that is, here, more long shaped? So we have here a building that is not just a simple building, it's more complex, it takes further. Then, of course, the circle approach is not what we want, but then we would just really fly around this object, which means if I just draw it, that means we just take this as a shape and then we would really just fly around the area here in the same distance in the part. So that the distance here from this here to the object, so this distance here is the same like this. So I would probably fly here a little bit further. This distance here, this distance to here. Again, because then the scale, in this case, of the images and the given content is the same. Again, we don't need that one image is viewing the whole building part, in this case here. So in my case here, if I go to our camera view, here, look, so this is my camera here. And if I now go here further away, and I put this now here perhaps on 25mm, then this would then here be my camera. Let me perhaps remove my constraint here. Here, just looking straight. And then this would then be my content. And then I would need now to fly again different flying heights. That means this image here is seeing these windows. So I want that the next image on the next flying height is still seeing perhaps the bottom part of these images. So it means if I go up here, then I want again to go at this height and take again pictures. Then I want again to climb up higher. Then I want to have these images, these windows in the next flying height. So I go up and then I take here these images here. And then I still cannot see the roof part here. So then I would go up even here above the roof and take these images here. I could even go a little bit higher. And then, of course, for example, then put some oblique on the images down here. So here means I rotate it a little bit down, and then I could still see here the roof, but also these windows here. And then I would here fly around this object here, or this around this area of interest with the same procedure. That means, again, I want to try here to take this image, then I go in this case to the right side. I want to have then 70% overlap, which means I want to have these two windows at least being visible in the next part. So that means I go here to the right, and then I take here my next image. And then I take again here my next image, and here my next image, and here my next image. And then of course we see now from the height, this makes not so much sense, but still I would, because of simplicity, because if you want now to start every single image to tweak, it's no fun. And then you go around, and that's why I would not fly in a square. Perhaps let me correct this here. Makes more sense then. Go here in a circle around this part here, and then go here, and take again here these pictures, and same procedure here, going in a circle around here, and coming back to here. And then move my camera and just visualize it here. Take this image here, here, take it again here, here, take a picture here. And then same procedure on the next height. So then I go here down and take the same pictures on the next height, and then again taking a picture here, rotate, and then continue. I hope this explains now again how we can get the same scale. We can therefore have objects of similar resolution. We also, our final result will then have in general a same homogeneous resolution, and will give us also all the details. So for example here, the challenge would then be, how do we want to get here this lower part? And then of course here it makes sense then to fly with your drone very narrow to the ground, to take here the inner part of these parts also to be captured, so that we can also here model this part as good as possible. And same thing is here on top, where we also see here, for example, probably this was by a drone generated, so they didn't take, they did it like me probably. So it would make sense then here to again with this distance, let me grab my camera here. So let's go a little bit closer here, and then let's move a little bit up here. So here we go, and rotate it a little bit down. So also to take here pictures from this part here, so that we also can model this part here, which means then again same distance. Let me here show it. So my area of interest here, same distance is then flying here around it some images. So I grabbed in here my camera, and we can see it here a little bit here. So this is my first picture, going here, next picture, around, next picture here. And then we would also cover, this is important for us, with a high detail. Of course, some parts are really, really difficult. So if you want to reach here in this background, then this will be really a big challenge. But it could be possible. I don't know if they took Nadir images, like I mentioned, then from top. Then this can also then allow us to cover this part here. But in general here, we can still see it is well part. You see also here, probably they took straight 90-degree images. So that's why sometimes it also makes sense when you fly here on this height here. Here, my camera, right? Bring my camera over here. Let's rotate it here. And we can now see we're looking now a little bit down. I want to change this here. So let's move our camera here down and rotate it a little bit up. So this can also sometimes help if you are interested to get here underneath the roof here this content also. So because if I stay here straight, let me here stay straight. Typically, I fly a little bit higher here. Then this is the content that we see, so we don't see so well underneath it. This can also help. Okay, final part still. I mean, you need somehow to organize it simple enough. So in this case here, flying here, same distance. So this circled, squared, half box, half circle. This would make a lot of sense. And then flying it again on different heights. You remember here, let me here make a double. So also adding here 1 here, adding 1 here at this height. Not a circle flying, but just to cover here the whole content. Taking images here so that 70% overlap in this line is covered, and also 60% at least, I would say, in the height. At the beginning at least, this makes a lot of sense. And then you have already a good starting point. Then of course complexity, so if this is very important, then here adding, and also if this here is very important, taking here images also from a lower part would also help. And then we can here finally also fly on top of the roof, at least 2 or 3 strips, Nadir case, just to complement the whole part. And then we would have this data covered. So in this case here, this curve here is half a curve. So let's take every 10 degrees. So we have here 18 images, here 18 images, so 36. And then here along, we have then here probably an additional 20 and 20. So we have then 36 and 40, so 78. Let's take 80 images, and then we take this on 5 different steps here. So 80 mal 5, so 400 images, and then also the Nadirs on top. Let's add some other 81, and then we have here 400, 480, and then some special images, 20 more, so 500 images to cover this building in a good way would probably make a lot of sense. This data set. And I hope this helps you for getting a good idea about 3D modeling with photogrammetry. Concerning the control points, it's similar like the Nadir case. That means we want to have, if we place a control point on the facade, then we want at least to have it on 2 different flying heights covered. If you put it on the ground, then don't make it too close to the corner, so that we can also have images from this part, but also from this part seeing it, if possible. keep it 2, 3, 4, 5 meters away from the building, so there are more images seeing the target. I would recommend to have both on the ground and on the facade targets, if possible. Therefore, RTK solutions for the drone are always helpful, so you need lesser control points and you can still reach a very high accuracy with it. I hope this gives you a good general approach how to run 3D modeling with drones. Thank you. Goodbye.